So we are going to see role of conservation laws, role of conservation laws in classical field theories. So you might have in your earlier classes known, for example, angular momentum. Angular momentum as a quantity is due to some rotational symmetry, or charge conservation. It's the some phase, some phase remains constant. You can derive charge conservation from phase properties, phase invariance of certain quantities. In the same way, you have to see how then the conservation laws, how they are, since we are studying quantum field theories. So we have, and before we are going to study quantum field theory, we have to first see the formalism of Lagrangian field theory or Hamiltonian field theory, how we can embed them in the classical field theories. So some properties, the conservation laws या conservation properties जो यहाँ hold कर रहे हैं, so they should have some analog somewhere in some symmetry principle. They should have some analog, some correspondence in a symmetry principle. फॉर एग्जाम्पल ए क्वांटिटी उसका अगर डायनेमिकल एवोल्यूशन भी करेंगे स्पेस टाइम में, फॉर एग्जाम्पल स्पेस में भी करेंगे, टाइम में भी करेंगे, ठीक है, स्टिल दैट क्वांटिटी रिमेन्स कांस्टेंट, ठीक है. सो व्हाट इज दैट व्हिच रिमेन्स कांस्टेंट? even if we make some transformations, even if we make some changes or transformations, so it turns out there are some deep principles in nature जिनको हम symmetry principles कहते हैं. So this was basically discovered by Noether, and in Noether this correspondence. So in the sense, for example, and they can be generalized to different properties. Now the thing is, what is, once we change something, and what are the symmetry principles which are required to make the conservation systems possible. अब हम इसी चीज को हम mathematically this link is called Noether's theorem. अब ये है कि how we can make the statement of the Noether theorem. So we do one thing. We make a infinitesimal transformation. हम क्या कर रहे हैं? हम infinitesimal transformation कर रहे हैं x mu. So if there is some coordinate, you go from x mu to. So the infinitesimal transformation can be rotational transformation, linear transformation, ठीक है, or some transformation in the charge, or some transformation basically in the Lagrangian or the Hamiltonian of the system. तो अगर कोई system change हो गया from x mu to x mu plus delta x mu, so and उसके साथ जो corresponding field quantity which is associated with it, if it's phi r of x, change in field, then phi prime r of x is phi of r of x plus so some change in some coordinates, so the corresponding change in the fields goes from this to plus this. Now the change in the Lagrangian is like this. So अगर change in the Lagrangian ये है हमारे पास in that sense, so rather change in the Lagrange density, we can say, for example, Lagrange density को हम change करते हैं for the sake of brevity, we can say normally it's functional depends on phi, and we can have its first order derivative. Just like in Taylor's theorem, you can have first order derivative, the second order derivative, and higher order derivative, and so on and so forth in that sense. So like that, we have a change of transformation x to x prime. So we assume that, for example, अगर window आपने correspond किया change from x to x prime, you say, for example, in that sense that you say once you change x to x prime, the field in 5 to 5 prime doesn't change. ठीक है, as if for example अगर हम vectorially एक क्वांटिटी चेंज कर रहे हैं यहां से यहां तक गई, मगर अगर यहां से यहां तक गई, अगर आप उस कोऑर्डिनेट सिस्टम ही को चेंज करेंगे कोऑर्डिनेट, सो इट डजंट मीन दैट एनीथिंग हैज चेंज, बिकॉज़ से इज कांस्टेंट रहा नहीं. सो आपने अगर इसको, सो यू कैन यू ट्राई टू इमेजिन इट लाइक दिस. सो इफ x change to x is if as if so you can say, for example, अगर हमारे पास कोई वेक्टर फील्ड है, it means as if the coordinates got rotated. The distance between the 2 points may remain same, but the coordinate itself got rotated. ठीक है, in that sense. So that the modified variation हमारे पास जो आएगी, it will be with a change in the coordinates है, so which means that value of x fixed and only takes into account the change of shape of the field. ठीक है, now अब ये दो, we have two sorts of variations are there which we have to take into consideration. For example, अगर हमारे पास changing coordinates ये है variations, you can relate it like this. This is delta phi r, है ना, ये एक कोऑर्डिनेट से, so infinitesimal change going from this to this. So you can write it like this, either phi of r x minus phi prime r prime x prime plus phi prime r x prime minus phi of r x. So I have introduced, देखो मैंने ये इंट्रोड्यूस दो बार किया. You can cancel with this, it's same, ये ना this term. We have only used add. इसे क्या करेंगे हम? What we do is this thing. इस चीज को हम, since it's changing phi r, you can see it here. It changes from x to x prime. So if it changes from x to x prime, it means it's delta phi of r x. So infinitesimal change between two coordinate systems. And अब इसको आप माइनस को यहाँ लाएंगे, you can just write it like this. सॉरी, हमने इस और इसको दिस एंड दिस, ये भी एफ आ रहा है ना, फाइव, ये फाइव प्राइम और एक्स प्राइम माइनस ये दिस क्वांटिटी। दिस एंड दिस को यहाँ रखा, फाई आर माइनस फाई आर प्राइम, दिस एंड दिस, फाई आर माइनस फाई आर प्राइम के बल ये लिखा, दिस एंड दिस एंड दिस एंड दिस, वी कैन राइट इट लाइक दिस। ठीक, फाइन फाइन। Further what we can do is we can write it like this, we can write it like delta phi r x minus, so you can say it's a infinitesimal change of function phi r x minus, so you can write it as a sort of derivative ये तो अपना है ही है, so you can write it as a derivative of so infinitesimal change in derivative of changing function phi of r x prime minus x, so infinitesimal change को हम ऐसे भी रिप्रेजेंट कर सकते हैं, ठीक है। such that we have used the first term, the Taylor expansion, such that we can say in the lowest order, such that phi r prime x is replaced by phi of r x, so this is replaced by phi of r x। यह है ना phi of r x प्राइम, तो ये यहाँ पर phi प्राइम r है, तो यहाँ पर भी हमने लिखा phi r x, इसको भी हमने phi r x के साथ रिप्लेस किया, हाँ, बिकॉज ऑफ सिमेट्री। so we are taking first order Taylor, the Taylor expansion in that sense, or we can say it's valued up to first order infinitesimal or first order variations कि ये भी वेरिएबल है। एंड इसका जो मॉडिफाइड है, वी कैन सी it should have this commutation property, should be equivalent to del bar so rate of change of this infinitesimal derivatives, अगर डेरिवेटिव को बाहर लाएंगे it should crisscross, but आप देखोगे this property will not always hold, this property will not hold, for example variation of delta, so infinitesimal variation of delta doesn't mean that the derivative of that delta variation, they are one and the same thing, so इस property को हम कैसे, how can we see this property, so how can you see this property, so this property can be seen like, for example if I just make यहाँ पर थोड़ा सा, so if I make one thing, so d by dx mu delta phi r can be written as, so उसका अगर हम लेंगे ग्रेडियंट इस फंक्शन का ग्रेडियंट लेंगे, so you can say it d by dx mu phi of r prime x prime minus d by dx mu phi of r x, so you can write again, you can write it so है ना, we can I have used the same two terms, we can cancel, we can हमारे पास ये दो terms रहेंगे, so you see हमने यहाँ पर डिफाइन किया था, यहाँ पर ऐसे वी हैड डिफाइंड दैट दिस टर्म. So from this, if you have to define things this way, so you have to see here. Agar you can write it like this. ठीक है. सो अगेन अगर हम इसको यहाँ मल्टीप्लाई करेंगे, अगेन मल्टीप्लाई इट बाय dx mu by dx mu. तो आप देखो यहाँ पर so we have got these two terms and these two terms. So you can see, if you want to इसको है ना यहाँ पर delta phi r. Delta phi r means delta phi r is equal to delta phi r. So you can use this thing as if we have to write d phi r by dx mu plus d phi prime by dx mu. तो इन दो टर्म्स के बदले we are going to write as like this. इसका डेरिवेटिव भी अगर हम लेंगे d phi r d phi r d phi r. So इस चीज को हम थोड़ा सा सिंप्लीफाई करेंगे. It will come out to be like this. Or you can say delta where in the last step we have used the identity like this. Identity हमने यूज की dx mu by dx mu is equal to g mu plus delta x mu by dx mu, which is valid only up to first order. Means how do you see it like that? G mu is basically 1 0 0 0 1 0 0 है ना, वो 4x4 मैट्रिक्स है. ठीक है. एक्चुअली ये G mu is basically symbolic. बेसिकली ये 1 को डिनोट करता है. ये ना टेलर सीरीज एक्सपेंशन है ना, जैसे 1 plus x to minus टाइम बार plus x square by 2 factorial. So you can say G mu is 1 to first order derivative, फिर second order derivative, फिर higher order derivative. हाँ, depending upon the indices. अब इसी चीज को if you want to write it in terms of some matrix form, you write it in some matrix form. So it will this equation जो हमने ये exercise की यहाँ पर, so इसका form आएगा हमारे पास. So we are basically seeing what? We are seeing Lagrangian density of a field phi going to phi prime, corresponding to coordinates x going to x prime. So something remains conserved, and that conservation can be seen in the form of an action integral. Should remain action integral remains what? Constant. ठीक है. So action integral remains constant. मतलब so it means d4x ये 4 डायमेंशनल इंटीग्रल है इसका Lagrangian, and the infinitesimal change of Lagrangian from Lagrangian density from x prime to x या x prime to, so it should come out to be अब ये you can say should it come out to be zero or should it come out to be constant in that sense. So what we'll see, so the infinitesimal change in Lagrangian हम लेंगे ऐसे, हम ये लेंगे ये है ना वो space time manifold, it's the change of Lagrangian in space, three space coordinates है वन टाइम में उसी का स्पेस टाइम मैनिफोल्ड बनता है. तो इसका ये आएगा, सो यू कैन हैव d4x डेल्टा एल एक्स प्लस d4x एल ऑफ एक्स माइनस d4x एल ऑफ एक्स. ये भी एल एक्स है, ये भी एल एक्स है. सो दिस इज द infinitesimal change of Lagrange. So going from L to this. So once you go from that to this, what's the infinitesimal change of Lagrange? So from symmetry principles, it should come out to be some constant. And if we want to write it, the transformation को हम लिखेंगे in terms of, if you are going to write this transformation in terms of some, what I should say. We are going to write this transformation in terms of some determinant. हम इसको लेंगे, we are going to take Jacobian of a determinant. Jacobian क्या कहते हैं? You have some matrices, you have a coordinate, उसका derivative लेते हैं, how it relates with the other coordinate. ठीक है? How we can introduce Jacobian as a determinant to relate two quantities as derivative of that determinant. ये करते हैं. So you can say d4x is mu and mu space time coordinates. This can be. So अब ये है कि हमारे पास हमने यहाँ ये रिलेट किया ना इसके साथ 1 plus first order derivative. So it can be like this: 1 plus d delta x0 by delta x0, d delta x0 by delta x1, so on. इसी तरह ये भी 1 आएगा, फिर ये आएगा डेल्टा x1 by डेल्टा x0, फिर डेल्टा x1 by डेल्टा x1, डेल्टा x2 by डेल्टा x, ऐसे करके. तो दूसरी टर्म आएगी इसकी, इसका 1 plus ठीक है. So you can have this symmetric term. So you can have 1 plus this, 1 plus delta x1 by delta x1, delta x2 by delta x2, 1 plus delta x3 by, तो इसमें ये आएगा. So you can have these symmetrized 4 cross 4 matrices. You can have, अगर इसको हम, if you want to sum up, you can write it as 1 plus है ना 1, you can write it 1, ये पहली टर्म. So you can have odd diagonal terms also. So you can have mixed tensor also, mixed derivatives also. If mu is equal to mu, so you can have these diagonal terms, है ना, x00, x11, x22, x33. So other terms can be encapsulated here. And d4x is a space-time manifold in that sense. So now we are coming to proof. Proof last 2-3 steps, which will encapsulate what we have done. It will take me 10 minutes. डेल्टा डब्ल्यू कैन बी है ना, हाँ, यू कैन हैव इन्फिनिटेसिमल चेंज इन लैग्रांज, ये है अपना, एंड दिस इज द लैग्रांज इटसेल्फ। हमको लिखना है ना वेरिएशन लैग्रांजियन क्या आया, लेकिन ट्रांसफॉर्मेशन फ्रॉम फाइव टू फाइव प्राइम और एक्स टू एक्स प्राइम, सो इट विल बी सॉर्ट ऑफ लाइक दिस, और now what we are going to do is we are going to see this is the action integral। अब हम डेल्टा एल को देखेंगे, ठीक है, डेल्टा एल चेंज इन द लैग्रांजियन गोइंग फ्रॉम लैग्रांजियन का चेंज विजावी फील्ड डेल्टा फाइव और प्लस So if you try to see again, you just इसका आप simplify करेंगे। After simplification, you can see, you can write it in terms of, for example, you can write phi r। Phi r को if you remember, हमने phi r को यहाँ पर लिखा था, phi r को हमने ऐसे लिखा था, delta phi r was phi r prime x minus phi of r x। Now you have to substitute phi r here, phi r here. Once you substitute these equations, you will get some more terms, and in the end, so I'll write it here. So it will take a couple of more terms, and it will take this form. Now you see, it will turn out as if we are again the way we came yesterday to the Euler Lagrange equation, है ना? Whatever the exercise we did. Here also, once we did this action integral का, इसका हमने LDT लिया, change in the Lagrange, and यहाँ पर substituting the value of L in terms of phi in terms of this, the equation took the form as if again we are coming to this equation, and now this delta x को हम substitute करेंगे, है ना, एक यहाँ पर substitute करेंगे and एक अपना हमारे पास L है। If you do it here, this equation interestingly will take this form, it will take this form। Plus so it will take here, इसका इस ये फॉर्म आएगा। इस फॉर्म को हम लिख सकते हैं as, अब देखो, अब हमारे पास if you remember, if you want to वी कैन राइट दिस डी बाई डी टी सबको, दिस क्वांटिटी को डी बाई डी एक्स ऑफ डी दिस। तो ये हमारे पास है ना यहाँ पर। अगेन आई जस्ट फॉरगॉट इसका एक सिंप्लीफिकेशन हियर इज लाइक दिस। अब now we are coming back to equation 242 को। हाँ, हमारी इक्वेशन जो पहली वाली इक्वेशन थी, ये वाली इक्वेशन, दिस। So we have done changing this and first order changing this, where phi r को रखा था इसके बराबर। So now what we are going to do, we are going to see इस सब को हम ऐसे लिख सकते हैं, इसको बाहर निकालेंगे। डेल्टा फाई आर यहां निकलेगा, यहां पर डेल्टा फाई आर के बदले लिखेंगे ये दो टर्म्स, एक्स न्यू प्लस लैग्रांजियन देखो, एंड द फर्स्ट टर्म, इसमें दो टर्म्स आती है, दिस टर्म प्लस दिस टर्म। ये टर्म जो हमारे पास है, इट इज एज ए लैग्रांज इक्वेशन ऑफ कोएफिशिएंट टर्म, सो इट कैन टर्म इफ it's equivalent to 0 if the Lagrangian term comes out to be constant। जो सेकंड टर्म आ रही है ना, सेकंड टर्म को हमने अगेन मल्टीप्लाई दिस बाय सब्स्टिट्यूशन। तो इसका मतलब क्या है, नाउ कम्स द मूट पॉइंट ऑफ द क्लास, व्हाट डू वी गेट एट द एंड, हम कहां पर पहुंचे। सो द थिंग इज so we have arrived at, so if this and if it is 0, so this entire quantity you can write it as, if सब को यहाँ से यहाँ तक को, if we represent it as f, we represent it as f, it's a sort of conserved current, d by d x mu is f of mu x, it's as if it's a current density, it's as if it's a current density. Current density form you can take it like that. If it is that, then so if it is that, so we can say that f mu x is dl x by d of del mu phi of r delta phi of r x अब अगर ये करंट डेंसिटी है, देन इट्स इक्वल टू 0। इट मीन्स दैट अगर इसका हम वॉल्यूम इंटीग्रल लेंगे तो इसमें हमारे पास है ना ये 4 स्पेस टाइम इंटीग्रल है, It's fourth space-time integral. So you can say f mu x. हाँ, you see इसका ये फोर्थ स्पेस-टाइम इंटीग्रल है ना, इसमें 3 स्पेस-टाइम कोऑर्डिनेट्स है, 1 टाइम कोऑर्डिनेट है. So you can break this integral like this, and f represents this entire quantity. यहाँ से यहाँ तक. Actually यहाँ पर दो टर्म्स आती हैं. First term will be constant of zero due to Lagrange equation of function. The second term, it is a sort of conserved, a current. Okay. So if it is conserved, then this entire thing will be zero. So it's zero in both space. तो टाइम कोऑर्डिनेट में है x0 एंड स्पेस कोऑर्डिनेट में है ना, दिस स्पेस कोऑर्डिनेट है ना, μ0, μ1, μ2, μ3. So ये टाइम. So what does it mean? It means that अगर डेरिवेटिव को बाहर, टाइम इंटीग्रल को बाहर लेंगे एंड इसको बाहर लेंगे, again you can use Gauss divergence theorem, so you can take it surface integral. So you can say surface value of surface integral at the boundary vanishes, ठीक है, and the derivatives fall suddenly at infinity. इसका मतलब ये है कि the quantity is not only conserved in time but it's also conserved in space. So we have arrived at the statement of the Noether theorem, which says that G is equal to so if I just write a statement which will encapsulate whatever we have done in the thing. Each continuous symmetry transformation leads to a conservation law, and this G can be obtained. G can be obtained with the use of these two equations. Okay. So what should I summarize? थोड़ा सा इसका proof थोड़ा cumbersome है, but the idea is simple. We are taking quantity 5 to 5 prime, coordinates x going to taking उसका first order infinitesimal लेंगे, then making the corresponding changes क्या आएंगे Lagrangian में, and towards the end हमने क्या किया, we arrived at after modified variations and use of Jacobian determinant उसका मैप करके at the end we arrived at two equations. एक equation आई as an IR equation and this as a current. IR equation will be constant or zero. So this current को हमने कहा at boundary or at a given time it will always remain. From this statement we can arrive at Noether theorem. ठीक है, as a proof, mathematical proof. Fine.